Today's presentation will provide an overview of SSH and the Open SSH product. We will begin with a description of the service and its use cases. Then we will discuss how to install and configure the service. Finally, we will address some security risks associated with SSH and offer 3 tips for hardening its security. SSH, or Secure Shell, is a protocol that enables the establishment of a secure and encrypted connection between devices. This allows users to send commands through a command inline interface, such as PowerShell. SSH is widely used in organizations that operate mainframes. Some common use cases for SSH include remote server administrator, file transfer, secure access to internet services, remote connections to private networks, and bypassing firewall restrictions. In today's work environment, many organizations have multiple offices locations, server locations, cloud-based applications, and remote employees. Managing a distributed network requires administrators to securely access all devices without needing to be physically present. Although there are several protocols that can facilitate these connections, SSH is a secure option that encrypts data during transmission. SSH establishes an encrypted connection between a user's device and a remote device, allowing data to be transmitted securely across this connection without exposure to intercepting third parties. The benefits of using SSH includes protecting against common attacks such as eavesdropping and connection hijacking. SSH operates within the TCP/IP protocol suite, which describes how devices identify one another using IP addresses and how they determine the correct recipient for data. Once the data reaches the intended IP address, the Transmission Control Protocol (TCP) takes over to maintain the connection and ensure that data packets are sent and reassembled in the correct order. The default port for SSH is port 22. Linux and Mac systems provide built-in SSH services, while Windows machines require an additional SSH client for support. OpenSSH is the open source variant of SSH. For Windows, it requires Windows Server 2010 or later, and PowerShell 5.1 or later. SSH can be enabled in the GUI by navigating to Server Manager and enabling remote SSH access. It can also be enabled in PowerShell using #start the SSHD service, #start -service SSHD. To establish a connection using SSH, return to PowerShell and run the command SSH domain / example username at example server name. This will present a yes/no prompt asking if you would like to add the server to the list of known hosts. It would also request the device password to establish the connection. In an SSH connection, in addition to cryptographic key authentication, most secure devices also require the user to authenticate using a username and password. For Linux, OpenSSH can be installed using the command sudo apt install OpenSSH-client for the client application and sudo apt install OpenSSH-server for the server application. SSH can be configured using various commands that control communication and the authentication settings. To connect to a remote device, use the command SSH example user at example _remote _server _IP. If the remote device does not use the standard port, again port 22, you will need to specify the port in the command. There are also additional commands available for creating SSH keys. Using OpenSSH involves executing various commands. While we won't go over each command in detail right now, the following list of common commands can serve as a helpful reference guide when you start using SSH. These commands cover the generation, management, and storage of the encryption keys required for SSH. In practice, administrators use these commands to establish secure connection, manage user access, and ensure the integrity of encrypted sessions. The ability to generate and control keys is particularly crucial as it guarantees that only trusted devices and users can authenticate with the server, thereby reducing the risk of unauthorized access. While SSH is a valuable tool for establishing remote connections, it also presents several significant concerns that IT professionals should consider. First, there is the issue of SSH tunneling. Tunneling involves routing packets of data through a protocol or path that they wouldn't typically use. SSH facilitates this by wrapping data packets with headers and altering their destination. Specifically, SSH employs a method known as port forwarding. This allows a user to remotely connect to a device and perform actions that will generally be restricted, as these actions appear to originate from a different device. Second, we must address SSH keys. These keys provide users with root access to servers, which is a major security vulnerability. Effective key management is essential, especially for a large organization with numerous keys. Unmanaged keys pose a risk similar to that of a compromised username and password, yet they're not often monitoring as closely. The NIST Interagency Report 7966 offers a comprehensive overview of SSH key management. Lastly, we should consider firewall weaknesses. SSH can bypass firewalls because it operates on port 22, which many organizations leave unblocked. Despite the security concern associated with SSH, it remains a powerful tool if configured to enhance its security. The first recommendation is to operate within a zero trust environment. Zero trust is a security model that restricts access by default, regardless of whether users are inside or outside of the network. With SSH, a hacker who gains remote access to any device on the network could masquerade as an internal user, potentially gaining unrestricted access to data and systems. In a zero trust environment, even internal users are granted access only to the specific information they require. This approach shifts the focus from defending the network perimeter to continuously protecting all aspects of the network against threats from both inside and outside. The second recommendation is to implement hardware multi-factor authentication. Given the security risk associated with SSH, using physical devices for multi-factor authentication offers the highest level of protection. These hardware tokens provide an additional layer of security to key-based authentication, as the physical device must be present to complete the authentication process and establish a secure connection. The third recommendation is to utilize DNS services. SSH servers should be configured to perform DNS checks, ensuring that the connection accurately corresponds to the correct hostname and IP addresses combination. By implementing these hardening techniques, organizations can safely permit the use of SSH within their networks. However, continuous monitoring should be established to ensure compliance with security policies and to prevent SSH from being used to transmit data outside the network for any unauthorized purposes. This concludes the presentation of SSH. Sources used for this information in this presentation are listed here.